Welcome to Data Skeptic Time Series.
This is Data Skeptic Time Series, the podcast about how to predict the future based on historical sequential data. Episode number. Climate is indeed a dynamic system, but with satellites regularly photographing the surface of the planet, a visual time series dataset becomes available. In raw format, these images are not obviously useful. Researchers have to do some data transformations, increasingly using machine learning techniques, in order to identify characteristics they're interested in measuring and studying. Today on the show, I speak with Daniel Omeiza about his work predicting land use change in the Nairobi area of Kenya. We discuss that work as well as Daniel's work on AI safety.
My name is Daniel Omeiza. I am a PhD student in the Computer Science Department of the University of Oxford. My research is on Explainable AI in autonomous driving. This research I'll be talking about today, I did it with one of my professors about 2 years ago during my master's program.
To kick things off, we'll start with the imagery problem. I guess to set the stage, would you mind providing some background on urban growth, especially in Sub-Saharan Africa? What's the nature of the problem you were looking into?
Yeah, I think urbanization is a common phenomenon in developing countries like in Africa. And there's this trend of lack of park planning and management, which is resulting into, the encroachment of urban fabrics into reserve or special regions, which of course could lead into unsustainable increase in population. So my research at that time was actually to study the growth rate of how urban lands are being used and perhaps do some forecasts to inform the decisions of urban planners and relevant stakeholders so that they can adequately prepare to handle the urban growth and the influx of people from rural to urban area, basically.
So I live in Los Angeles, California in the U.S. It's a very urbanized place, and I don't think there's even an inch of land that isn't accounted for. So if you want to do something here, it has to be planned out and bureaucratic and things like that, which I guess in some ways makes it predictable. How much predictability is there in the way the landscape is changing in the data sets you looked at?
Well, I think that's a very difficult question because there are no data sets available out there for land use especially in Africa. And I would like to discuss about this in detail because the data set actually used to make predictions or rather to classify land based on land use was outside Africa. And it was a data set from Europe. But the paper that presented that data set or that provided the data set actually had this claim that the data set was representative and was got from different parts of the world, from developing countries, from transitioning countries and undeveloped countries. So based on this information, so we used the data set and trained a model that could dictate different kind of land categories. So there are no data sets. So answering the question as per predictory nature of this kind of factor in Africa, I think is really difficult to respond to. So but I think my research was just an attempt to see if that was actually possible and if any result is going to make sense, trying to predict with just the limited amount of data set we had from Africa.
It is challenging to have a data set that's sort of out of sample like that. If it only came from European countries, it may not be representative of the areas you're looking at, but not so unrepresentative that you didn't use it, right? There must be some use in it. What are some of the limits you think that exist there? Are there ways in which Sub-Saharan Africa is sort of fundamentally different from those European cities that are understood today?
When I was selecting the classes that I was interested in, I ensured that I selected the classes that were also present in the African landscape. So for instance, we had commercially built up areas, we had parking lots, we had residential areas. So all these areas are common areas that are obtainable in Africa as well, especially Sub-Saharan Africa. So since we have this type of areas from developing countries represented in the original data set I used, so I felt that it would be worth trying out to use this original data set and apply it in the context of Sub-Saharan Africa, basically.
What are some of the labels you're interested in being able to classify for?
Yeah, so the labels include commercial area, dense residential area, freeway area, open spaces, meadows, medium residential area, parking lots, road junctions, and sparse residential areas, and also charapel. So there are about 10 labels, 10 classes for the data.
Gotcha. So at least with the data set we were discussing, you have a labeled data set. Are there options out there? I mean, they're less useful maybe in some sense, but is there data sets that contain no labels that you might be interested in looking at as well?
Yes, there are data sets in Africa that would have been useful, but they were without labels. Another challenge or another limitation was the fact that the data set was not as large as I wanted to be. So I opted for this other data set that I eventually used. So I feel there are other data sets especially in Africa, but are not large enough and they are not labeled, of course. So I think it's a very serious problem trying to get labeled data set from Africa for land use cases.
As an aside to that, you said those images exist, so certainly some effort could be put into labeling. I don't know how grand or complex that might be, but are you aware of any efforts or do you have any recommendations for what it would take to get something like that done?
This will require like crowdsourcing, and especially crowdsourcing from people who live in those areas, and giving them some kind of incentive, and also providing some kind of internet data, because data is kind of a very expensive commodity in that part of the world. So it's a high cost expenditure if you're going to try to label such kind of data that belong from Africa. So at the moment, I don't really know if there's any attempt or any effort by any organization trying to label the existing data or collect data that is labeled. But I think it's a very expensive thing to do, especially from that part of the world.
So then you've got a data set in hand of satellite imagery data, but that feels a little bit raw to me. It's not like you're just going to give a PNG file to a machine learning algorithm. What has to happen to prepare that data?
Basically, the research I divided into like 4 phases. So first of all was the collection of data, and I had 2 different kinds of data in the research. So the first data I used from, they call it Northwestern Polytechnic. They released this data set of about 5,000 size data set with different, I think 45 labels or 45 classes. I only picked 10 classes common to Africa, and I trained a deep learning model on this data set. So then I obtained satellite imagery of Kenya, Nairobi part of Kenya, from 2004 to 2018. So how did I get this satellite data? So I explored different categories of different types of satellites imagery, and I discovered that Google Earth images were the best option. So I retrieved these images. They were in JPEG format, and what I did was I had to do some pre-processing after I've already trained the model on the initial data set. So I collected this Google image data set that are very large, and now I have to do a pre-processing. The pre-processing involved the removal of cloud components from the images. Some of the images were covered by clouds. Some were totally covered by cloud that I could not even do like proper cleaning. So I just have to remove those data and do some kind of image interpolation to create new data. So that's one of the steps I followed in pre-processing the satellite imagery that I retrieved from Google Earth. And the next step for me was to use the model I trained on the initial data set, that data set from Northwestern University, to do like a segmentation on these Google satellite images. So I use a technique called patch-based prediction to use some sliding window effect, sliding over the very large Google Earth image and predicting the class for each of them and painting them, doing some in-painting as I go along. So the end result of the Google Earth image is now a segmented image based on land use, basically. So for the original data set, high pre-processed, well, the data was already cleaned. That's the Northwestern Polytechnic data. It was already cleaned and ready for processing. I think it's about, forgotten the dimension, and I think about 250 by 250 by 3. And so I didn't have to do any serious pre-processing in that initial data set, but rather I had to do in the one I got from the Google satellite.
So the clouds example is kind of interesting to me. Am I correct in assuming you want to filter those out because effectively clouds are hiding the ground and you'll have a label that says, oh, this is, a highway intersection, but of course there's no way you could learn that when you just have white fluffiness in the image?
Yeah, so cloud is kind of a noise on the data sets that we retrieve from Google Earth. So when there is cloud, it is very difficult to identify the actual property of the land area contained in the image. So we just see white cover on the image, and the machine cannot learn anything, or perhaps the predictor model cannot predict anything because now it doesn't understand what is contained in that portion of the image, basically. So we had to do that pre-processing to remove clouds and where they exist and remove those that are actually really bad and use image interpolation to create new ones, basically.
In some regards, it seems like you have a very classic image classification problem. We have the images and then some labels about how the land is being used. For listeners that are familiar with image recognition, hot dog or not hot dog, this is something that technology is at this level now. Did you have to do anything unique for your problem to approach this, or could you kind of follow the standard playbook seen in other research?
Yeah, I had a standard. I actually followed like the normal process for image classification, building a classification model to classify images based on land use. And this involved creating a baseline method, use some ablation process, and improving the baseline model I have with a benchmark in mind. Eventually, I got to the level of accuracy that I was interested in. And when I had that accuracy, I applied this model to the satellite imagery I obtained from the Nairobi area of Kenya.
Very cool. Could we zoom in on that? What sort of metrics did you look at to evaluate the quality of the model?
Yeah, so the quality of the model, basically I used, of course, the cross-entropy loss functions to actually measure how the loss was dropping, how the loss was reducing, and AUC-ROC curve to actually estimate the performance of the model, use F1 scores as well to check how the precision, the recall properties of the model, and also use confusion matrix to see those items that were misclassified and those that were properly classified.
Yeah, that was something that was interesting on my read of the paper. When I look at the confusion matrix to see, where is it making mistakes, they're all kind of intuitive mistakes, not silly mistakes, if you know what I mean, that it would confuse an intersection with just a roadway, where I could see myself making the same mistake. With that in mind, do you have any ability to benchmark this against like a human user or a known result? What's the state of the art in a task like this?
Yeah, so the state of the art, there is a benchmark work I used to benchmark this model. Somebody used similar data sets previously and trained the data set on the VJGNet architecture using transfer learning approach and obtained some accuracy, I think about 90% accuracy. Meanwhile, I tried to use a transfer learning approach with ResNet and discovered that the accuracy was not satisfactory enough and did not even reach the benchmark model. So I decided to just build my architecture from scratch and just try, continue doing some tricking, hyperparameter tuning, and eventually I obtained an accuracy that was slightly above the benchmark model, which I think was the state of the art at the time. So as for human evaluation, I did not do any evaluation using any user study or talking to people about it I didn't benchmark with any classification that any human has done in the past.
Thanks to this week's sponsor, Oval Edge. Oval Edge is a cost-effective data catalog designed for end-to-end data governance, privacy compliance, and fast, trustworthy analytics. Our end-to-end data governance suite has flexible solutions at a fraction of what other providers charge, starting at $100 per user per month. If your company hasn't addressed compliance yet, you need to get on that right away. If they have, it's always important to double-check that you have the state-of-the-art and the best possible solutions. One of the reasons a lot of companies delay solving these important issues is because they don't really know what to do with their personally identifiable information, or PII. You need it to operate your business, but you owe it to your customers to protect them. But you don't have to do that alone. Oval Edge uses AI to crawl all of your systems. They have a suite of data classification features that can help build your data catalog in an automated fashion. And that's not just your standard run-of-the-mill databases, but it's also BI platforms and ETL tools and data lakes. Anywhere your data lives, they can help. Download their Implementing Data Governance Guide and schedule a demo by visiting ovaledge.com/dataskeptic. That's ovaledge, OVALEDGE.com/dataskeptic. So you built the model on the labeled data set and then applied it to the more generalized data set from Google Earth. In some cases, I could see people running into challenges where the model was in some way overfit to the original data set or even just to the artifacts of how the photos are taken, something along those lines. Did you face any challenges in getting the model to generalize onto this never-before-seen data set?
Yeah, I was really careful when I was building the architecture because I had this in mind that having sometimes two complex architectures with several layers could lead to overfitting and that the model might not generalize appropriately. I use some penalization approach when building a model, like dropping noisy data at some point within the convolutional neural networks layers, and that's one of the approach I use just to ensure that my model doesn't overfit. And this, we cannot really confirm this because we have no ground truth to actually evaluate if our model is doing well or not on the Google Earth dataset. But what's from visual inspection of the segmentation made by our prediction model on Google Earth image, we discovered that the segmentation actually made sense. Like the parking lots were rightly segmented, the middle or the parapet were rightly segmented, and the dense residential areas were correctly segmented, basically. So I think that gave some kind of idea about how our model was performing, and we could leverage on that to do some forecast.
Very cool. Yeah, let's get into the forecasting. So far, we've talked about it primarily as this image classification problem, even though you have a longitudinal data set measured quarterly over many years. With this, I guess, tool in hand of the ability to now label these, what do you do then to make that into an interesting forecasting problem?
So now that I have a data set of images that are already segmented using our classification model, so I have these images from 2004 to 2018, so we have a total of about 60 of them. And now I take each of these segmented image and do a pixel count for each patch, let me put it that way, and trace it up till 2018. So now I have like a data series from 2014 for each class up till 2018. So now I have the dates for each of these images or each of these data points, dates, and what the pixel count was for this particular region at so date. So I had that for all the classes, and now I created an ARIMA model, make a prediction for what would likely be in the coming years, I think from 2018 to 2021.
With that ARIMA model, can we zoom in on that a little bit and talk about its output and maybe how you envision that being used? Is this something an urban planner can take and use in policy in some interesting ways?
Not confidently so, because now we have the ARIMA model that is predicting what land use values will be from 2018 to 2025. But we don't have a way to evaluate this, right? Because we didn't even evaluate, there was no quantitative way to evaluate our classification model on this segmentation approach. Secondly, there is no existing model or similar work that have been done in that space that we benchmark with. So the confidence level as per how this work could be applied in real life is actually really low. But one thing is sure, that now we have an idea of how land use progresses. Is it declining? Is the amount of land being used for different categories, is it declining or increasing? We have image differencing to show how land use is changing. We have segmented image with labels showing different areas and the corresponding labels that people could use to make informed decisions, probably. For the ARIMA model forecast result, I do not have much confidence on that model, to be sincere. But for the segmented images we provided, I think they are really something interesting and could be explored further in the future, because now we have the image segmented with different portion of land indicating different kind of land uses, and each of them has labels. So this could give a historical insight of what has happened in the past and see the progression, how land has been growing, how it has been reducing from in the past, and they can use that to make informed decisions for the future. So I don't really trust the predictions our model makes.
Well, it's healthy to be skeptical in that way. I'm curious if you would speculate about where there is a need for improvement. I don't imagine this is a fruitless exercise. There must be some improvements that could be made with additional effort and time and energy, but maybe there's a ceiling as well. I mean, people could wake up in the morning and make a decision that day about how they're going to change the landscape, and the historical data might not reveal their choices. So do you have any thoughts on the long-term success of approaching methodologies like this?
Yeah, so I think the only way to do this is start collecting data sets by Africans in Africa and now labeling these data sets. And that's the only way I feel we can have a more trustworthy model we can place confidence on to make predictions for policymakers. Because making policies is very critical, and whatever decision is made at that level affects life. So we can't be depending on a model that we don't have much confidence in to make policy for the masses. So I feel that first we need to get correct data, accurate data sets from Africa, collected and labeled by Africans, and we can start playing with the data set, trying things out, benchmarking with other people's work on same data set, and now we know what is a good model and what's a bad model.
And in that regard, I'm curious, in terms of improvements, do you think probably there's lots of ways you can approach it? You could explore other methodologies, different statistical techniques, or maybe you just need more and better data. It sounds like you're in the data camp. Is that a fair assessment?
Yes, kind of.
Maybe to wind up discussion about this particular project, before we ask you a few follow-ups about your current work, do you have any vision, in addition to what we've talked about, in terms of where studies like this should go? Is this a practical thing that policymakers would benefit from, but for the fact that not enough investment has gone here? Or is this more of an academic pursuit for the time being?
I think there's strong potential for this work, and this is just a starting point, and to show people that something like this is possible and could be done for Sub-Saharan African space. As for me, I think I already stopped that line of research, and I am onto something different at the moment. But I encourage anyone else who is really interested to just take it up and push it, and let's see what's going to come out of it, and how policymakers can benefit from the resulting output.
Well, you'd mentioned at the beginning that you're working now on autonomous driving a bit. Could you expand on what you're exploring there?
Yeah, basically, I switched over from the line of work we just discussed to Explainable AI, and that's what I've been working on for the past 2 years. So I've been just exploring how to explain decision of deep learning models, and what's the rationale behind models, and how do they learn from input to generate some output. And in that respect, I developed this technique called the Smooth Cam some time ago, which is gaining some traction at the moment. So I'm trying to now apply some of these theories and background I have in Explainable AI into explaining the decisions of autonomous vehicles, being that they are complex AI systems, or they are made up of complex AI systems, and or rather deep learning models, and they have a very large decision space, high dimensionality, which even supersedes human. Sometimes could lead to confusion if a human is to make such a kind of a decision when it has a large sample, large set of variables to choose from. I am leveraging on the perception data sets from autonomous driving, and also trying to make use of these data sets to explain the actions of autonomous vehicles when they drive. So the perception data sets involve the exteroception data and the preprocessing data. So we get data from the CAN bus, which shows the internal states of the vehicles at each timestamp, and we have the exteroception data, which is data from maybe camera, the LiDAR, the radar, and we try to fuse this together and find a way to generate explanations based on road rules, observations, and actions, basically. I want to see how these explanations will be relevant to the respective stakeholders, and the two main objective I have for the explanations I'm generating is intelligibility and causal attribution. So I want the explanations to be intelligible to the relevant stakeholders that will be utilizing them, and I also want the explanations to make references to causes, like they should explain their decision based on internal factors and external factors that has caused an effect, basically.
And who's your audience with that in mind? When you say it needs to be explainable, I think if you were the audience, you yourself who understands deep learning and things like that, the car could give you a highly technical specification that you find interpretable. But maybe the average person who doesn't know about ResNet and things like that wouldn't appreciate the same interpretability level. Do you have a sense of the audience that needs to be satisfied by the autonomous vehicle's explanation?
We have different stakeholders in mind. One of the main objectives, because I talked about intelligibility, like explanations should be comprehensible enough, should be easy to understand by even lay users. My target at the moment is the public, lay users, and who would want to trust autonomous vehicles, who want to have confidence in autonomous vehicles, because I feel that developers already understand what they are building and they want to even use it, right? But the public are still skeptical about this technology. So how do we give them this assurance of safety? How do we make them build confidence on this system? So the stakeholders targeting for this solution are just the general public who may not have an expert knowledge of machine learning or AI. Not just that, I'm also targeting regulators. So now we have a different explanation set that I want to provide to regulators and accident investigators. So have a log of explanations when you query this system over a particular time space, and they're able to provide the explanation log, and the accident investigator can investigate an accident or an incident based on the explanation log they've got. So the same thing for regulators based on explanation logs, and they can learn the behaviors of vehicles, know how the behaviors behave, and see if they have to review some regulations so that AVs could be safer and more reliable.
Well, we're seeing some autonomous vehicles on the road today in different parts of the world, but really in testing ways. Companies are trying these out. But for sure, the goal is to have a more mass release where the average consumer can buy one. Do you think we'll have the explainable AI in place before these hit the streets in a mass fashion?
Well, regulations are being set currently, standards are being built at the moment, because as far as I'm concerned, to the best of my knowledge, there are no standards. Of course, we know regulations like the GDPR are saying that machines should explain their decisions to users, but there are no standards that are specific to autonomous driving. And currently, researchers and the industry are coming together to come up with this kind of standards. So I feel that this is a major requirement for mass deployment of autonomous vehicles, because when there are issues, we want to be able to investigate the issues easily, and explanation provision is one of the way to do that. Maybe they might come out concurrently, perhaps, or we have the vehicles, being deployed first, and we'll have different iterations of explanation systems getting more robust until we have, very sophisticated and easy to use explanation system that could be integrated into autonomous vehicles. So I think it's just something that we have to keep iterating on and making it get better as the vehicles are being rolled out, subsequently.
Well, Daniel, is there anywhere people can follow you online?
Yeah, I have a Twitter account. You can follow me on Twitter. I usually post about my recent works on Twitter.
Excellent. We'll have a link to that in the show notes so people can follow up. Well, thank you so much for taking the time to come on and share your work.
Thank you very much.
That concludes another installment of Data Skeptic Time Series. Thanks to our sponsor, Oval Edge. Our guest today was Daniel Omeiza. Myself is Claudia Armbruster, Associate Producer. Vanessa Bly does guest coordination, and our host, Kyle Polich.